Hello everyone. In today's video, we'll be solving this question, which is a 0-1 knapsack problem. From here on, we'll be solving uh, uh, like a set of dynamic program pattern based questions. And the today's pattern that I've taken is a 0-1 knapsack problem, which has 4 questions in it. As in, there are 6 actually, but then in this video, we'll do the first 4, and in the next video that is related to difference, we'll do like we have 2 more questions that is related to difference. We'll do that in the next question. This today's video is mostly like based on some base problems. So yeah, so these are the problems that we'll be solving today: subset sum problem, partition equals subset sum, target sum, and perfect sum problem. So I mean, this is what I was practicing right now, and I guess so. These are the 4 questions that we'll be solving, but before that, we'll have to understand what the knapsack pattern is. So yeah, you are given weights and values of n items. So we are given the weights and values of n items. N is 3, and we are given three number of values and 3 weights associated with the values. So put these items in the knapsack of capacity W. So you are given a sack basically. Just think this to be a sack. So you're given with a sack or bag which has the capacity of W. That is, you cannot store any, like you can store a maximum of W weight in it, W kilogram, not more than that. But you can definitely store less than that if you want to. But to get the maximum total value, so all you have to focus on not filling the weight of the bag, but to gain the maximum value out of it. Like there can be a possibility when your bag is not filled, but even then you're getting a maximum value. Let's say if I take an example of your weight of the bag is 8, let's say, but you have 4 or 5 items with small values of 2 kgs each. So let's say if the weight array is weight array is 2, 2, 2, and 7. Okay, I mean weight array is 7. Okay, yeah, and value is 1, 1, 1, and let's say we have one more 2, and let's say one more 1, and value is this is 1 weight, and the value is 200, something like that. So in this case, even if let's say there can be a possibility wherein we have this combination of 2, 2, 2, 2, which fills the bag, but does it give the maximum value? No, it does not. So the value we will get is 4. But let's say if we take these, I mean any 3 2's and this 1 1, so the value we will then get is 200 plus 3 2's, right? So that the total capacity of the bag will be 7. So even if the bag is not filled, we are getting more value out of it, right? So that is what the question wants to do. All we have to do is to increase the value as much as possible. So in other words, given two integer arrays value and weight, which represents values and weights associated with n items respectively. Okay, so these are with respect to each other. The first item of the bag has a weight of 4 kg and its value, and the first item's value is 1. That is what they mean. Also given an integer w, which represents the sack's capacity, knapsack's capacity. Find out the maximum value subset of val such that sum of the weights of the subset is smaller than or equal to w. So you have to maximize this value by filling the weights which is less than or equal to w. It cannot be more than, but it can be less than. All we have to do is to maximize this value. You cannot break an item, either pick the complete item or don't pick 0. So there is no possibility wherein you take the fraction of an item. All you can do is to take it or to not take it. So basically that is also a gist of how you should identify a problem to be a knapsack problem or not. Like these are knapsack problems because these hold a common property. That is, during the solving of the questions of these problems, what we do is we either we have 2 options, either to take an item or to not take an item. So that is what we usually do. And that is how we usually identify whether a problem is a knapsack problem or not. So having told that, we can start coding it. Like how do we do that? Well, basically I'll do that using recursion. I can do that using tabulation also. Okay, fine. For this one problem, I'll go with the both recursion and tabulation method, but I am a fan of recursive method. I don't know why, but like that seems to be a little more intuitive to me. And so that is why the rest of the problems that I'll solve this using memorization only. I mean the recursive solution only. So yeah. So first, what we're gonna do is we are given with the size. We are given with this. Okay. Now we'll create this function by the name f, and that will solve the problem for us. So f will have w, weight, value, and n, passing that. But we'll have to. Okay, fine. We'll memorize it later on. We'll just go through the recursive solution for now. So this will be integer return type function. This will take w. This will take w weight. This will take the value, and this will take the n. Having taken that, now what? What will the base case? The base case will be simple. The base case is the case which is the smallest of all, like the smallest case that you can. So what is the smallest case here? Here the uh, which are the parameters that will be varying? There will be two parameters that will be varying. What are those? This weight, yep, and this n and y. So the weight array that is given to us is this one. I'm explaining this with ultimate precision because you just copy paste same code here on here, here, and here because these are essentially the same problems. Like, these are based on abstract problem. So that is why I'm focusing a lot on this problem actually. So values is 1, 2, 3, and the weight is 4, 5, 1, right? But after one iteration, if we are starting with let's say n, it will change to this, right? It will change to this because we have either taken that or not taken that. Irrespective of what we have done, we have processed that value. So having processed that value, the size of the array gets decreased, right? Or else it will be an infinite loop. If we do not decrease the size, like we increment the value of I in a for loop, I is equal to 0 to n. So here we are decreasing from n is equal to n to n minus 1 to 0. So that is what I mean. In my problem, what I'm doing, I will pass n only, and the operations that I'll do will be n minus 1 based. So for n is equal to 1, I'll mean literally that my value array and weight array will have one value in it, but index wise I'll take n minus 1 into consideration. You'll understand that while I code it. That is what. So this is varying. But let's say we have taken this value. If we have taken this 3, the knapsack, this is the knapsack's weight, right? I mean, this is the maximum weight that I can hold. But then if I have taken this 3 in my knapsack's I mean weight will be reduced by weight minus 3, right? Because I have stored this 3. I stored this 3. So the original capacity will be no longer valid because we have stored that 3, and uh, hence the capacity of the knapsack decreases after each iteration. So we have two variables that is sort of changing, and those two variables are n and w. So that is why the base case is also dependent on the variables that is changing. So there can be two possibilities here. If n is equal to 0, n is equal to 1. Yep. No, n is equal to 0. Yeah. N is equal to 0, why? Because the size of, yeah. This is not, again I'm saying that n is equal to 0 means our array has no elements. So that is what I'm not taking 0 based indexing here. I'm taking 1 based indexing here. So n is equal to 1 would mean I'm having one element in my array that is stored at index 0, but that is not n, right? N is that one element that is existing. So here n is equal to 0 means our array is empty. So in that case, will return what? 0, because there is no profit that you can generate if you have no elements in the array, right? There is no value that you can generate because you have no you have no value, the value array is empty. So that is what it essentially means. And if the capacity is empty, if the either if you are going to steal in a gold shop, let's say, to steal the gold items, ornaments and stuff, so there can be two possibilities. Either your bag is full, then you won't be able to keep anything in the bag because it is already full, or you have no bag, that is the capacity of your bag is zero. So in that case also you cannot take anything, or I mean, given you are not putting something in your pocket, like the condition being you can only take things in your bag. So either your bag is empty and you can fill the value, or your bag is not empty, as in it is full, so you cannot take any gold items. So there can be two possibilities when you cannot steal gold items. The first one being your bag is having no space or you have no bag, that is the capacity of the bag is zero, or there are no gold items in the shop. That is the second possibility, right? There is no gold items in the shop. So in both the cases, return zero. And in order to cut these two short, I'll put an or condition. So even if any of these is valid, we cannot store. I mean steal. I mean you cannot keep the values in your bag. So this is the basis. Now what? Now, now there are two cases. If weight of I told you that I'll index wise I'll take the zero based indexing, so I'll have to do n minus one, okay? Because see, if there are seven items, the seventh item is stored in the sixth index. So in order to access the seventh item, I have to do weight n minus one, right? Seven will be I mean junk because that is the size, and uh, the values in the array are stored from zero to size minus one and not the size. So if weight n minus one, there can be two possibilities. Either you can take it and you cannot take it. I mean, you have no choice, right? Either you see, in this case, you'll have two choices, right? If the weight of n minus 1 is less than or equal to weight, like the amount of gold present in the shop is less than or equal to the amount that you can take. So there can be two possibilities. Either you take everything or you do not take, right? So in that case, what we'll do is return you take. If you take, you will have the value. You have the value, so you'll take the value plus. Since you have taken it, the weight will be weight minus WT of n minus 1. Since you have taken it, the weight reduces, and WT array will be as it is, value array will be as it is, and since you have processed that item, will go n minus 1. That's it. And there is another possibility what? You do not take, you do not take. So you have to take the maximum of both. Maximum of take and not take. So maximum of that you have taken, this condition is what? This condition is that you have taken it, and now I'll write the condition when you're not taking it. Maximum of, so if you're not taking, you won't have any val. You won't have any of this like val and minus one thing. This term won't be there. So for the simplicity's sake, we'll write 0 plus, since you're not taking anything, f of, since you're not taking anything, the weight, you still have all the weight with you, right? The capacity of your bag does not get decreased. So wt val, and but since you have not taken it, either ways, if you have taken it or not taken it, you've processed that item, you cannot come back to that item again. So there is another version of knapsack that is known as unbounded knapsack, in which you can come to that, you have the option to coming back to that element again. In that case you do not do n minus 1, but here since you have processed that item, be it taken or not taken, you have to put n minus 1. So having done that, yeah. And the second case is when the gold items, the current gold item that you're taking, right? See, this is not the entire, see, this is what, this is not the entire jewelry shop. This is one item in the jewelry shop, right? So if you have entered in a jewelry shop to steal, pardon me for taking this bad an example, but like this is very simple to understand. If you're going with a bag to rob a jewelry shop, you'll go one by one, right? The first item you go to, you see there is a small ring, so you know that you can keep the small ring, and that small ring has diamond in it, so that will be valuable, so you'll keep that. But let's say if you're going to you're going moving forward, you see a very big watch which is made up of silver. So you know that even if it is made up, I mean even if it is large, it might not have that value because that is silver, right? That is not diamond ultimately. So, and another case wherein you have this very big thing which is made up of diamond, but you cannot store that thing. So because your bag has no capacity, so that is the case I'm talking about here. If the weight of that particular item which you are at, that particular item which you are at right now at this point in time, if it is greater than the capacity of your bag, you cannot take. So you have just one option. You have just, there is no max case here, you just have one option. One option of what? One option of not adding any value to your bag, so 0 plus, no reduction in weight, since you cannot take that van, and you have processed that item. You know that, okay, fine. If you are moving from left to right, you know that this big watch I cannot steal because this is very big. This cannot come in my bag. Let's move forward and see if there is any small watches or any other items that I can take. So you have processed that item for at that point in time that I'm not taking this. Okay, fine. I won't come back to this again. So I'll go to the next item now. So that is what in -1. So yeah, this should possibly solve the question in my viewpoint. Yeah, it does. But then this is pure recursive. This is pure recursive, and you cannot afford to, use pure recursion in dynamic programming. See, you got this error of time limit existed. So what we'll have to do is have to memorize it. Vector int n plus one vector int mm, plus one comma -1. Initialized everything with -1. Pass dp. We'll copy this. Pass this as parameter. Address bias because we want to you know make the changes get reflected in this array. Dp array. Dp 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 return dp of which were the two elements that were changing, the n that was changing and w. We'll store that return. Okay, why do we use dp? Because if the element is already processed, if dp of n and w is already processed, that is it is not equal to -1, return that value. As simple as that. Don't worry, we'll go through the tabulation approach as well for this question at least. I mean, we'll go with for all the questions, no issues. No issues. We'll go with both the tabulation and recursive approaches in both the questions. So I hope you would have understood the approach. And this will this will solve it. Yeah, it did solve. And now let's go to the tabulation approach. We'll just comment these two things out. In tabulation, what we do is we just store whatever we did in the recursive format or the memoization format in the form of a table. And the table usually has the rows representing the size of the array, right? In this case, the rows will represent n. So we'll have to make a dp table that is of n plus 1 size, and the column represents what? N plus 1 size row wise, no? And the column will represent the weight. Column will represent the sum or weight or whatever. So in this case, weight is the parameter that is changing, so that will be column. So weight plus 1 is the length of columns that will make. And tabulation approach has, and that is exactly same as what we do in recursion, but this base condition in the tabulation changes to what? In base condition in tabulation changes to initialization condition. So what we'll do is we would need this table dp table. I mean we'll use the same dp table. Okay. So having initialized this to -1, should we initialize this to -1? No, we should not, because this is, I mean, see, dp is completely different from, what do you say? Uh, okay, fine. Mm, okay, let me explain how it is different. See, table in dynamic table, what we do is we initialize certain rows based on our assumptions, or like based on the base cases that we extract from the question statement, problem statement, and from there we start building up as in filling up the table. And by the time we reach at the very like bottom right, that is we've processed all the columns of the columns and rows of this dp table, we get an answer at the very end, like the dp of n comma m, like the very last index of the dp that it can go to, like bottom rightmost is will be our answer. So that is how. So we cannot initialize dp with anything. I mean we can of course, but then there is no purpose of initializing dp. So that is what uh, we'll write a dp array of n and w. N plus 1 will go to n w plus 1. You can go to w plus 5 also, I mean, for the sake of, sometimes it throws up errors, but n plus 1 usually depends on question statement actually. So we'll have to initialize it with what? See, if we form a DP, like imagine if we are forming a DP table of uh, n number of rows and w number of columns. In this case, that will be, in this test case, it will be 4 rows and 5 columns. What what is the value that we can initialize this to? Let's say if n is 0, right? That is, if number rows is 0, can we have, like, if the rows n is 0 means we do not have any values, so it will be initialized to what? 0, of course. It will be initialized to 0, right? And if w as in, yeah, this is also 0, I mean j is also 0, as in j is 0, that is weight is, mm, n is 0, that is we are not taking an element. Yeah, w is 0 means you do not have any capacity. So in both of the cases, the first case you do not have any values given to you, it will be 0, and the second case you do not have any weights in your bag. In both the cases it is 0, same to what we have written here. So that is what we will do. If I is equal to 0, I is less than or equal to n I plus plus for int j is equal to 0, j is less than or equal to n j plus plus. In both these cases, in both these cases, mm, the dp of I and j will be equal to 0, right? Either the shop has nothing in it or your bag has no capacity in it. So in both of the cases, it will be 0. Fine. I have initialized this, but if no, I have, yeah. If I is equal to 0 or j is equal to 0, we put dp of I and j is equal to 0. Having done that, now what? Now let's see here. There can be two possibilities wherein the capacity. No, see, this is something that we are not. This is something that we do only in memorization. But this is something that we can do in tabulation as well. So if weight of weight of I minus 1 is less than or equal to, see, just change, keep on changing it. Weight of n is what? N is I said, right? N is the number of rows and w is the number of columns. So w is essentially j. So and n is I. So weight of I minus 1 is less than or equal to j. What you do? You take the maximum of it. Take the maximum of, you write dp of ij is equal to max of what? Here what you're doing? You're taking that value. You're taking that value. So max of value of I minus 1 and f of c. This is something that is recursion, right? So we're not taking a recursion here. So what we'll do is we take this value, or we do not take. So dp of, in table what we'll do is, what you did, you call this recursive function. Okay, fine. So yeah, in case of you're taking it, what you're doing, your weight value, that is your j parameter. J parameter will, okay, fine. The I parameter will be reduced by 1 first of all. I parameter is n, right? So n will be reduced by 1 first of all. We have reduced that one. Okay, fine. Next iteration you go with n minus 1. That is what means in recursion. And I minus 1 and j parameter is reducing by weight of I minus 1. Weight of I minus 1. So what will pass? J minus weight of I minus 1. I hope you would have understood. This is little complicated. I know it is not that intuitive, but then the way I'm trying to, refer to the memorization code and then converting this, all we did is converted all the n's to i's and all the w's, that is columns in our table. We are changing that to j. So j is now the new weight is j minus. We have processed this item, but then the value of the weight will be reduced, right? So that is what we are reducing it here. Max of this, max of this, and what? The second case is we're not taking anything. We're not taking anything. So yeah. So 0 plus. In that case, only I parameter is changing, and j is remaining as it is. So dp of I minus 1, like we have processed this item, and j. Else if weight of I minus 1 is greater than. You cannot put this in your bag because it is very large. But it is dp of ij. Since we are not taking it, just this 0 plus 0 plus dp of I parameter is changing, it is getting reduced by 1, and j parameter is what not changing because we are not taking, so effect on weight will be nothing, right? So that is what. And then at the very end, I told you that this will keep on processing from the uh, top left to bottom right, and all we have to do is to return this bottom right, and that will be our answer. dp of n and w. This will be our answer. Hope this is correct. Hmm. Is not equal to j. Take this value. This should not be an issue. Where did I mess up? Hmm. Yep. Uh, we did a small mistake here. Small, no, actually very large. So W it should be here, and this should be fine. Ayo, still not fine. Hmm. That was a really bad error, and I want you guys to take note of it. That what I did was this was if here, so this will cause a problem because there can be a case wherein since all these conditions are under one for loop, there can be a possibility when this is also true and this is also true. In that case, this value gets updated to this value, and that is not zero initialized. Like either you what you do is you create another for loop outside and then initialize that to zero and then you come here, but then that will also again overwrite the issue. So that is the problem. So we are overwriting our own initialization with this condition, right? If it is if case here. So and this will have a snowball effect because if any one of the column is wrongly filled, it will affect the last column, right? Because these columns that are later in the matrix gets its value from the columns that are beforehand, like which gets filled beforehand. So that is why we should not override this, and we should write this condition else if. So if there is a case when this condition gets satisfied, then this condition won't be checked. This condition won't be checked because these are else if, and this is a part of this if. So if this if gets, yeah, this is a very good error actually, and glad that I found it. So that is it. So now if I submit it, changing this if to else if, it will go. It took a bit of time to explain this question, almost half an hour around, because these questions are very easy now. These questions, all these four questions are very easy. So, so now writing, now in this question, what are we supposed to do is, given an array of non-negative integers and a value sum, determine if there is a subset of values in it. Yeah, that this is the exact same question of this is, in this question we are given a weight and the values, and we have to find that we can, let's say, it with the weights or not, right? So if we change certain typical terms, it becomes the same. It becomes essentially the same. So what will we do? What did we do in that question? We'll just copy paste the code here. Copy pasted the code, and now okay, fine. Array array is something that we're given with. Okay, By the way, this is a very good habit of passing this as a reference, because this will ultimately, make your solution a little more efficient, because even if you're not making changes and you don't want the changes to get reflected, since you're passing this by address, the exact array gets transferred in the function also. So if you do not do by reference, if you do not pass by reference, then it will create a copy, and then that will add up to the space, to the solution. So the effectiveness gets reduced. I mean efficiency. So vector int, then sum. Okay, and we want one more variable, that is n, that is the size of this vector int. So what we'll do is int n is equal to array dot size, and we'll return f of array sum and dp. Initialize dp also, will copy the dp initialization from here. Oh, oh yeah, I removed the dp thing. Oh, take from the submission. Fine. Now what is this dp thing here? But here w is sum. So what we have to do is we have to change w. Wait, w is sum, and weight array is simply array. And then that was int, and here we have bool, int to bool, and rest of the things, yeah, is right. And since it is bool, this max will be changed to or, because max is what, maximum of 2, and or means what, if any of the two, right? So if any of the two returns us true, will return true. So we just have to find if there is a subset that sums up to a target value. That's it. So pass this sum plus 1, and we've created n number of columns, that is the size of the array, and some number of n number of rows, that is size of the array, and some number of columns. And this, you've passed these things, array sum n. Okay, these functions will also be changing accordingly. So array will be as it is array, weight is sum. Since you'll take this, right? So either you'll take this or you won't take this. So max will remove max, and we'll write or you don't take this. So here will f of, you take this. When you take this, the sum becomes what? Sum becomes sum minus array of, I removed value because we do not have to create maximum value, we just have to reduce sum to 0. So if the sum is reduced to 0 at some point in time, so we know that there is a subset. By taking or not taking a number of elements, we find that there is sum is becoming 0 from any positive value. So we have a subset that is reducing that to 0. So we'll return true in that case. So if sum minus array of n minus 1, n minus 1 is 0. Okay, fine. And value also we do not require, we'll pass n minus 1 here. This is the case when we take it, and this is the case when we do not take it. And if we are not taking it, the sum will not be reduced, but since it is processed, we'll pass this n minus 1. Similarly, if the, yep, here also we have to change, if only we can, when we can take is when ref n minus 1 is less than or equal to sum. If our array is greater than sum, we cannot take it, we are not taking it. So we'll pass dp of nw ni n sum, nw ni n sum. dp of nw is not -1, any positive value will do. N is equal to 0 or n is equal to 0, that is we get the array has no element. No, this is something which you have to change. Why? Because if sum is equal to 0, return true. I mean return 1. And if n is equal to 0, n will not, since n is size that you are passing, n will be 1. So if n is equal to 1, in that case, to further go and check if n minus 1, that is if array of n is equal to 1 means we have just one element, and that one element is at the 0th index. So if array of 0 is equal to the sum, return 1, else return 0. Fine. And if sum is equal to 0, then return 1. There will be one subset. Yeah, that is either we have found that subset here only, or there will be one, of course, that is the empty subset. So yeah. W was not declared. Okay. Ah, where is this W? 18th line. Hmm. Okay. 25th line. Sorry, my bad. Okay. Submit this and see. Mhm. Oh yeah, this will be 0, right? Because by default it will be false. -1. Time limit exceeded. Was the time limit exceeded? I guess. Return DP. Oh yeah, we are not taking it. We should not reduce the value, right? Why are we reducing it? Sum plus 1 0. Okay, fine, it is 0. If n is equal to 1, like if it has one element, okay, that can be a case of array of 0 is equal to sum, return 1. If not, return 0. Sum is equal to 0, return 1. dp n sum. So what this 2D DP array is doing is it is storing the sum. but we have to return this as a bool value, right? So I have to change the get function as bool. If n is equal to 1, I mean, so we have this one element, and if that is equal to sum, we'll return true, or else we'll return false. Sum is equal to 0 means we have this one option that is true. And if dp of n sum is not equal to -1, then return. So because this is storing sum, I thought, I mean, I misinterpreted this. This is storing sum, so it will be -1 by default. And yep, yep, it works. Go to this question, partition sum. This question will require this. Fine. This will tell if there is this sum subset sum equal true or false. Then we'll have sum is equal to 0 or false. If it is not equal to 0, we'll straightaway return what? False. Else create this dp vector. Yep, and then we'll return this. Sum by 2, since we are checking for the target sum. Sum by 2. N was not declared, so just capital N. Sum by 2. In solution, okay. So we'll just, if f of this returns true, return true, and return 1, else return 0. Okay, fine, this wants us to return anything by default, so return -1. Array sum by 2 and dp. Array sum by 2 and dp. In solution and interactive. I'm glad that was okay. Now this should